Assalamualaikum and a very good day I bid to all the viewers. So today for PHY 3902 Electromagnetism and Optic Laboratory for Dr. Abdul Rahman Sarmani, we are going to present to you experiment 6, magnetic induction.
Let's start with introduction. The principle says the lifted coil generated a magnetic field with a changeable frequency and intensity. The frequency, number of turn, diameter, and the field intensity all affect the voltage that are induced across thin coil that are forced into the long coil. The voltage induced in a secondary coil and turns cross-sectional area is obtained. The formula are formed from this. The application of the magnetic induction is transformer that's used to change the voltage level of alternating current. After we conduct the experiment, we get the 5 sets of the result, which if the table 1, we use the diameter and the frequency as the constant, which if diameter we set in 41 mm and the frequency in 10.7 kHz. We change the current and the number of the turn. Okay. For the table number 2, we use the current and diameter as the constant, which is the value of the current is 30 milliampere and diameter is 41 millimeter, and we change the frequency and the number of the turn. For the table 3, we use the frequency, current, and number of turn as the constant. The value of the frequency is 10.7 kHz, the current 30 milliampere, and the value of the number of the turn is 3000. We change the value of the diameter and induced voltage. For the table number 4, we use the frequency, current, and diameter as the constant. The value of the frequency is 10.7 kHz, the current is 30 milliampere, and diameter is 41 millimeter. We change the number of turn and the induced voltage. For the table number 5, we use the frequency, the current, and diameter as the constant. The value of frequency is 10.7 kHz, the current is 30 milliampere, and diameter is 26 mm. We change the number of the turn and the induced voltage.
The next part is result analysis and discussion. This is where we take the data that has been tabulated and we plotted a graph based on the data that we have achieved. From table 1, which we manipulate the number of turns in the coil as well as the supplied current, we plotted a graph of induced voltage versus current supplied. We can see that the induced voltage is increasing with the current supplied. And aside from that, we can also see as the number of turns in the coil increase, the maximum induced voltage obtained also increase. And from the graph, we can see that the coil with the highest number of turns, which is N equals to 300, and the highest current supplied, I equals to 80 milliampere, produce the maximum value of induced voltage at 1.051 volt. Moving on to the next table 2, which we manipulate the number of turns as well as the supplied frequency. It is the same as table 1, where as the number of turns increase, the maximum induced voltage also increase. And as for the supplied frequency, the increase in supplied frequency also result in increase of induced voltage. And from table 2, the graph that we plotted shows that the number of turns N equals to 300 and the highest frequency at 10 kHz produces the maximum value of induced current in that specific experiment at 0.382 volts. On to table 3, however, we are to compare the relationship between induced voltage and the diameter of the coil. Therefore, we used a set of coils with the same number of turns, but it is different in the diameter. We can see from the graph that we plotted that when the diameter is at the smallest, the induced voltage is also at the minimum, while as the diameter increases, which is at the graph is 41 millimeter, which is the maximum, it produces the biggest induced voltage at 0.409 volt. Table 4 and Table 5 is basically conducted to compare the effect of induced voltage when the diameter of the coil is manipulated. The coil used in Table 4 has a bigger diameter at 41 millimeters and is seen to produce more induced voltage when compared to the coil used in Table 5, which is at 26 millimeters in diameter, and it produces less induced voltage. This shows that the diameter affects the maximum induced voltage produced as it has bigger cross-sectional area. So from this experiment and all the data that we have tabulated and we have plotted the graph, we can see that induced voltage is affected by cross-sectional area of the coil, number of turns in the coil, current supplied, as well as the frequency supplied. And I would say that our data that we have achieved from this experiment actually match the theory, which is when the cross-sectional area increase, the induced voltage increase. When the number of turns increase, the induced voltage also increase. When the diameter increase, the induced voltage increase. And lastly, when the frequency supplied increase, the voltage produced is also increased. So all of 4 elements that we manipulated, when we increase those, it will result in a bigger maximum induced voltage.
Okay, we in the conclusion section. To conclude, induced voltage can be produced through magnetic induction. We observe that to obtain the maximum possible induced voltage in this experiment, the frequency should supplied at 10.7 kHz. Current applied at 30 mA. Diameter should be at 41 mm and has the highest number of turns at 300 turns. This result to the maximum value achieved by this experiment at 1.051 volt. Okay.
And that is all from us. Thank you for watching till the end of the video. So may you obtain something useful from our sharing. Thank you.